Hey everybody, Mr. Murray here, Mr. Murray's Mathland, and we're looking at another video here for solving a triangle for all missing measurements. And today specifically looking at the law of cosines. And the law of cosines is typically used when you are given either a side angle side scenario or a side 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 scenario. And there's a second video for the SSS case if you'd like to see one of those. And what we mean by that is just drawing a generic triangle here to represent what we've been given. Label it any way you like, A, B, C, just to help visualize these things. Side B is what's across from angle B. Side C is what's across from angle C. Side A is across from angle A. So we have been given side A is 21. We've been given side C is 17. And we've been given angle B is 28 degrees. Okay. So this is what we mean by a side angle side scenario. Look at what we've been given, two sides and the included angle. And a lot of kids like the law of sines in this unit where you're finding missing measurements. However, the law of sines, you need to have an angle side pair to really get going with that. And I only have one angle, but I don't have the side across from it to give me that angle side pair. So in the side angle side scenario, you're really going to want to use law of cosines. Now, law of cosines, I have the three variations here up in the right corner. If you are allowed to look at a formula sheet or if you have to memorize them, whatever. But one important thing to realize is that they're all the same formula. It's just three variations on the same one. And the idea is if you have side A here in the equation, if side A is the isolated one, and that equals the sum of the squares of the other two sides minus 2 times the product of the other two sides times the cosine of angle A. That's what I want you to notice there is that side A, if that's here, then angle A has to go here. Likewise, if you have side B isolated, then you've got angle B here. Side C, angle C. And there you go. So if you really know one of these versions, then you know all three. So in this particular case, we have angle B and sides A and C. So that's going to allow us to solve for side B. Okay, so we may as well just jump right into it here. That B squared, that's the side I'm going to solve for, is A squared, 21 squared plus 17 squared minus 2 times the product of 21 and 17, the two sides I do have, multiplied by the cosine of the included angle that I have, cosine of 28. And if I want to solve for b right now, I really can just take the square root of all of that. Now, if you'd like to, take your time and square these, add them, multiply this out, then subtract, then take the square root, that's fine. But I'm going to go right to the calculator here and do it all in one big step. So the square root of 21 squared plus 17 squared minus 2 times 21 times 17 times the cosine of 28. That's all inside the square root. And we get about 9.98, depending on how you want to round. Okay, and now we know side B, which means now you need to find angle A and angle C, and you'll be done. And you find either one of them. If I knew what angle A was, then I would know two angles, and I'll add up and subtract from 180 to get the third. So I really just need one more angle. And now I have my angle side pair. So I could use law of cosines, but a lot of people will use law of sines from here on out. If you want to use law of sines, the one thing I will caution you, and I know different textbooks kind of, bring up this point a little differently here. Law of sines, if you have the option, I tell my students, law of sines, find the smaller of the two angles. And of these two angles, A and C, which one is across from the smaller side? And that would be angle C. Since 17 is the smaller side, angle C must be the smaller of the two angles. Now, if you want to just know that and accept it, that's fine. But if you want to understand why, it has to do with the nature of how inverse sine or arc sine works, which is what you're going to be using in a moment to find the angle. For example, um, as you should know, we'll pick some familiar angles from the unit circle. The sine of 30 is 1/2 or 0.5. The sine of 150, that's in quadrant 2 with the same reference angle of 30 degrees, is also 1/2. But when you use inverse sine or arc sine, you should know by now that the restricted range, that output, is always going to give you an angle that's acute, from negative pi over 2 to pi over 2, or negative 90 to positive 90 degrees. So, for example, the calculator would give you 30 degrees. But when you are doing inverse sine or arc sine to solve for an angle, what if the angle is obtuse? The calculator is not going to give you an obtuse angle. So that's the thing, is that angle A right now, since that's the largest angle in the triangle, it could be acute or it could be obtuse. The largest angle doesn't have to be acute or obtuse necessarily. So I have a little bit of a mystery about angle A. But since angle C is certainly smaller, angle C must be acute, meaning I can trust what the calculator gives me as its measurement. So I don't know, hopefully that made some sense and didn't go on at too great a length here. But I say if you got the choice in using law of sines, find the smaller of the two angles. So here we go. Let's use law of sines now. Sine of angle C over that side C, 17, is equal to sine of 28 degrees, my angle B, over my 9.98, what I found for B. And then I'm going to multiply by 17 and take the inverse sine. I really can, again, if you're kind of a seasoned pro with law of sines by this point in the unit, you can type this in one giant step, isolate for the angle by taking the inverse sine of that. And when I bring that in here, and just to bring something back here, there was the side B that we found earlier. Now I rounded it to 9.98. But if I'm using that to find another part of the triangle, maybe you don't want to use just two places. If you want your final answer to be accurate, like this angle C I'm finding, if I want it to be accurate to two places, then I should either store that decimal and use that full decimal value in here, or at least type in a few more places beyond two places. So I can see it still on the screen, 9.978774. I mean, even that is going to help your accuracy so that your final answer for C should still be accurate to two places. Okay, so that's not ultra important, but just a kind of a noteworthy thing. So angle C is 53.11 degrees, and again, I know that it's acute because it's the smaller angle, so I don't have to consider its supplement. And now angle A is just going to be 180 minus those two angles that I do know. 180 minus angle B, which is 28, plus the C that I just found, which is 53.11. And angle A is in fact 98.89 degrees. So it did turn out that angle A was obtuse. And if you had, solved for angle A first by using inverse sine, using law of sines and then inverse sine, it would not have given you, the calculator would not have given you 98. It would have given you the supplement. It would have given you 81 degrees and change. And you would have said, how do I know if it's 81 or 99, So law of sines, find the smaller angle. Okay, so there we go. A little bit of law of cosines and law of sines mixed in the same problem, and some pitfalls to avoid. So hopefully this made sense. If you have any questions, hit me up. Otherwise, keep working hard.